Give me a moment, guys. I'm trying to open up SAS in my local itself so that yeah. So today's session will be more of business case, as I told you. I mean, so what business case will Anurag talk about, right? That's the next question. What will I talk about? If you remember, or rather, people who haven't joined the previous sessions, please feel free to look at the previous sessions. We were working with data that was termed as a credit data. So what it had basically is that it had information like, okay, if a customer has taken up a loan, right, taken up a loan, whether the customer has defaulted or the customer has paid the loan on time, right? So it had a column called default yes or no, which means that it captures customer behavior towards payment of a loan across some period of time, right? And if you're defaulted, the customer was flagged as default, otherwise not, right? So that is what you know. So let me try to break this into some moving parts. Okay, so how does analytics help you, or how does advanced analytics help you in this scenario? So let's talk about a situation where, okay, I know that out of 1,000 customers, I know that there are 100 customers who have defaulted this month and could not pay their EMI, right? Be it I mean, whatever type of loan, be it maybe a credit card, maybe be it a mortgage loan, house loans, friend loan, whatever, right? They were not able to pay back their money on time, right? So now, okay, so this is something which we know after the event has happened, right? But how can advanced analytics help us to take corrective or preventive action so that this event does not even happen, right? So in that interest, on those lines, uh, I would say a real business impact is actually driven by uh, advanced analytics. So what it does is that, okay, you imagine that you are a customer, you go to a bank and you tell the customer that, okay, I think I would need a loan, right? Obviously the bank does not directly, looks at your face and gives you a loan, right? There are multiple check boxes which the bank has to do, right? How advanced analytics can help you in that perspective? I mean, let's look at the data itself and let's try to understand. One is, before even sanctioning that loan to you, banks can be over cautious, or they can take necessary steps so that they don't lend out money to someone who does not have capability of repaying, right? So essentially what means that if I quickly open up an Excel, right, to start with, and show you what I'm talking about in step-by-step fashion, and then go on to in SAS to show you how would you build that model in SAS. Uh, that I think makes sense. Just trying to open up Excel. Just give me a moment, please. So if all of us remember the previous data which we had, right? I mean, I can show you that maybe to start with before going on to the Excel, so that you are also clear what I'm talking about. On that, we don't know what we're talking about, but yeah, let's look at the data which we used previously. How can we leverage that information to build advanced analytic solutions? This is what it looked like. I mean, the data was at a customer level. So for each customer, you had some demographic parameters like age, job, marital status, education, whether the customer is defaulting, yes or no. This is an important variable, right? Which captures if the person defaults in a loan, yes or no. Then at which month, then it covers a few of financial health of a customer, the balance, current month, previous to previous month. So these are more of your I would say variables which capture your financial health or financial stability of a customer, right? Followed by the type of loans you have, housing loan, right? This is more of personal loan. It's not tagged as personal loan, but it's personal loan. If you have a housing loan, yes or no. Followed by if you have a personal loan, yes or no. what is the duration, right? Essentially, these were the very broad, high-level things which we had in the data. Again, to reiterate, I mean, demographics followed by person financial health. So if you look at this column, guys, default yes or no. So I'm talking about this column right now. How can advanced analytics help you in this situation? Let me first of all lay down the use case. Okay, so imagine that you got a bunch of 100 customers, maybe, right? A bunch of 100 customers which are there. The other, for simplicity, the other bunch of 100 customers which are there. Bunch of 100 customers who come to your bank and ask you for a loan. Now, will the bank approve loan for all the 100 customers? Yes or no? No, right? The bank will select maybe 1 or 2 or 3 or maybe at max 10 out of these 100 customers to decide that okay, these are the customers who are actually eligible for my loan. Right now, how does the bank decide upon that? So, firstly, what it does that okay, if you closely follow this, you've got a bunch of customers for whom we know if they have defaulted yes or no. If you think about it in this way, can we assume or can we come up with some rules, some basic rules, not even going on to any statistical modeling or machine learning? Can we come on to some very basic rules to understand the customers who are defaulting? What are the type of customers, right? What is the average age of the customers who are defaulting? Or maybe who are the customers who are defaulting the most? Are they divorced? Are they married? Are they single? Who? So without even building a model, you can do a basic profiling to check that these are a group of customers. I mean, okay, it can happen that within this 100 group of customers, there can be some group of customers. Let's look at it in this way. This is a group of customer who is defaulting, maybe whose average age is maybe 28, and they're single. One group of customers, right? Another group of customers is, I mean, what I can find that okay, another group of customer I can find maybe the average is a bit more 42, but they are I would say divorced, and their salary is less than maybe 80,000 per month. Right? So in this way, you can create multiple segments to understand okay, who are the bad customers, who would actually tend to default. I think we are clear on those lines, right? So this is a first building block, I would say, right? How you can leverage data to take intelligent, decisions. So what you will do, you'll try to find lookalike, right? When a new customer comes in, now, right? What you will try to do, okay, try to fit the new customer within different buckets. So what is the age of the customer? Is the customer single or not? What is the customer salary? And by any chance, if the customer manages or falls within these buckets, these small buckets, so you can be very sure that okay, there's a high possibility that this customer will actually default, because we've seen that similar characteristic, right? But in actual world, that is not the way how you define policies, right? Otherwise, it's very blanket, right? It's, I mean, just covering 3-4 information points, data points, you cannot decide upon policies. So what would you have to do? You would have to build a full-fledged statistical model. Okay. Again, to recapture what I told, what will you do out of these 100 customers you have? Okay, whom came to the bank and you didn't go ahead and sanction their loan. You just sanctioned for 10 customers. This is the first step. What you will do for these 10 customers, you'll pick these 10 customers and capture information for these 10 customers. Out of these 10 customers, how many customers have defaulted even after giving the loan, and how many customers haven't defaulted. Essentially, you'll have a bunch of customers. I mean, if I want to, I would say zoom this a bit, zoom the greener portion a bit, right? So it would look something like this. You'll have a bunch of customers who haven't defaulted. Maybe these are customers who haven't defaulted. Let me make a different color altogether. The customers haven't defaulted, and the other customers who have defaulted. Okay. So this small green portion, I'm again trying to magnify a bit into a bunch of customers. So now the bank knows that these are the customers who default and they're the customers who don't default, right? So essentially, what will the bank do? The bank will try to build a statistical model or a machine learning model to capture what is the probability that if a new customer comes in now, okay, if a new customer comes in now at this point, what is the probability that this customer will default, yes or no? Okay, I think we're clear, right? If this is default, this is no, and this is yes. So you can actually create a statistical model to understand if a new customer comes into your bank, right, and asks for a loan, whether customer will default yes or no. Rather, my bad, not that exactly. So if a customer is there with you, right, a new customer is there with you, you do not know much about the customer's previous transaction history or something of that sort, but then also you should be able to predict that okay, whether this customer will default yes or no. That's the reason we build statistical models basis our past information. When you know that a bunch of customers have defaulted or a bunch of customers have not defaulted. So now you know who are the customers who will default, who are the customers who won't default, right? So there are a couple of things, couple of ways how, a couple of, I would say, very broad ways in which how you build statistical model. I think we've heard about this term previously. One is called the classification model, where you tend to get, you classify basically. I mean, simplistically, yes or no. In this case, it's a classification scenario, right? If it's yes or no, that's a classification model, right? So essentially, when you build a classification model like a logistic regression or something, so you would get a probability or a propensity for each customer that where this customer will default yes or no, what is the probability of defaulting, right? Essentially. So that is that is what you get from a classification model, yes or no. Moreover, from a logistic regression model, you get a probability where the customer will default or no, depending on the probability coming out for that customer. So that's one of the use cases which banks implement, right, to understand the probability that a customer will default yes or no, depending on their past behavior. So now, what do I mean by past behavior? I've been talking about, okay, these are the customers who got the loan. Now I'm amplifying this customer into a broader section. The blue are the ones who did not default, orange are the ones who defaulted. So now, how do I build a model, right? I capture multiple data points to build a model. So when I talk about multiple data points, I talk about data points like, one can be maybe, ratio of your balance, month over month, your credit score, number of months you stayed with the bank, month on book. Very broad. So even if I don't look at these very minuscule details, I can look at these ones. I mean, this will be simpler to understand, to comprehend, I think. One bunch of variables or one bunch of attributes I would look into is demographics. Right? More of to understand, okay, this customer, what is the customer all about? I mean, what is the age of the customer? What is the salary of the customer? Gender should not be taken into consideration because that's against laws and regulations. But yes, salary of a customer, age of a customer, occupation of a customer, right? So these are the typical demographic details. I mean, then what is the location? You are based out of which country, which city, tier 1, tier 2, multiple things. Demographic details is something which is used while developing a model to understand whether the customer will default yes or no. Demographics, followed by financial health, which I talked about right now. For financial health of a customer, there are multiple things you can look at, right? Financial health can be broadly classified into two sub components. One would be the data which the bank has. It's nothing but, so it's, I mean, the banking world, it's called on us data. On us is nothing but the information which the bank has about you. What it means, the bank knows how many products do you have. The bank knows what is your current balance. I mean, if you have a account with them, the bank knows, okay, do you have a loan or not, right? Then what is your current savings balance? How much amount of money do you spend every month, so on and so forth, right? So nothing but internal performance data which the bank already has about you. That's called on us. Second component which the bank has about you, which is actually taken from a third party called a bureau, right? It's basically a credit bureau. So I think for the interest of time, I won't deep dive onto that, but there are a few bureaus which are very prevalent and everyone knows about it: Equifax, TransUnion, and Experian. So a bureau information is nothing but information about someone, about financial health of a customer, not restrictive to the customer's financial health within the bank. So it captures maybe number of loans the customer has from all other banks, number of credit cards the customer has from all other banks, number of times they've defaulted across all other banks, all other cards. So this is again capturing financial health, but not from your bank perspective, but from the entire financial ecosystem. That's data what you have from bureau. So financial demographics is one, financial health is second. Honors bureau is nothing but again a sub part of financial health. We mark them in different color. So broadly, these are the type of data which you use from a perspective that you will develop a logistic regression or a classification model for a customer to understand whether the customer will default yes or no. Okay. Typically, yes, demographics, financial health, broadly these two. Okay. There are multiple other parameters which we can look into, but for now, let's think about these two broad things, right? So what you'll have these data. So the blue portion, nothing but data of customers from demographics angle as well as from financial health perspective. So you'll use all of these data points to develop a model. So essentially, a model is nothing but an equation, right? So I mean, if I make it very simple for you, if you remember in your school days or in your college days, if you have studied STEM, obviously, you have studied equations of straight lines, right? Y equals to mx plus c. So think of it in this case very similarly. You have an equation maybe which says something like this, that it's nothing but y equals to a x1 plus b x2 plus c x3 plus d x4. So this x1, x2, x3, x4, these are nothing but parameters of a customer. Maybe in this case, x1 is nothing but customer age. X2 is nothing but income. And x3 is nothing but maybe some other financial health. I mean maybe balance. X4 is number of credit cards. In this way, basically, y is a function of x1, x2, x3, and x4, right? And a, b, c, d are the coefficients, right? So think of it in this case, y in this case is default. You're trying to predict what will be the value of y, depending on these parameters. Okay. Simplistically, that's the way how you actually develop a model. I mean that is the basic math. I just wanted to show you the basic math for developing a model. Right? So now, can you develop a model by your own right now, and what will you do with that? Right. So these are the couple of things which I should talk about. Yes, in SAS, it's not very difficult to develop a model. There's a procedure called proc logistic which you can use. So obviously, I won't show you how to use it. I mean, in the interest of time, since it's just a 1 hour session, but I'll just write it over there so that you can have a better understanding about how to use proc logistic, I mean, at least you know that you can use POC logistic to build a logistic regression model in SAS, right? So you can explore that at your leisure. If you have any question how to use POC logistic, you can obviously get back to me or Board Infinity, right? So we are always available if we can help you out with that. So there's a function called POC logistic which you can use. Okay, so I'm not going to details, but that's something which you can use to develop a logistic regression model. And I can write the syntax right now to get the numbers for you, but in the interest of time, I'm not doing that. So now let's look at it. Okay, so let's imagine that, okay, for each customer, I have a default value that's probability. Right? Probability default. Yes, I mean, what is the probability? To try to create maybe a simulator data, simulate one data that's like a customer C1, customer 1, 2, 3, 4. Trying to make dummy data for now, just to make things clearer. My bad. So building the model is one portion of the puzzle, right? But how do you actually, action upon the output or action upon the model output? So till now we understand that, okay, there's a customer, there's a customer. So I'll have a probability of default. I'll have a probability of default for each customer. Okay. Randomly, if I have some random numbers for now, that works. I just want to show you what we can do with that. I have probability of default for each customer now. But what strategy will I take? I mean, that is the main goal of it, right? I mean, why do I build models? How a model can help me to make better business decision? Because always you have to keep this in mind. Analytics or data science is not about science experiments, right? It's the most important thing is driving business impact. If that's not been able to be fulfilled, there's no point in building a model, right? Now, how will you drive business impact? By developing a model. The next level comes is, okay, I have probability for each customer, that okay, there's a probability that this customer will default. The next layer comes into the action that, okay, how can I leverage this probability, or how can I leverage a model to take business decisions? Okay? That's the most important component. So first of all, deciding, okay, I have the probabilities right now with me. First step, I mean, very simple. I mean, the most simplistic strategy which I can think right now, without even doing any fancy jargons, right? Maybe just sort the entire thing with his probabilities. Okay, let me just copy and paste it. It completely went haywire. Okay. So what I'll do, I'll simply sort this with his probabilities. Now I know that these are the customers, right, who have the highest probability to default, right? These are the most difficult customers. Followed by these are the moderate customers who can default, who may default, who may not default. And the other customers, I think that the probability of default is really low. Right? So obviously, I have a marketing spend. I have a spend to reach out to the customers, right? Via different channels. That okay, if you think you will default, you can maybe convert your default, or you can convert your loan into some other schemes. Like for example, I'll give you an example. If you, I mean, during COVID, there was a situation where you could not pay back your monthly EMIs, right? So, including RBI, including many other central authorities of other countries came up with a strategy that okay, if you cannot pay back your loan, they give you a monthly moratorium, which means that okay, you don't need to pay for the next 3 months or 4 months, but after 4 months you have to again go ahead and pay the money back, right? So and that's an example of moratorium, right? So how do you decide whom to provide moratorium, whom to not, right? So first of all, to understand, okay, I think they're the most risky customers who will for sure default. So let me target these customers, okay? Also, there should be another layer, maybe your exposure, right? So if what do I mean by exposure? Exposure, nothing but a balance. the balance which is left, the amount of money which I'm defaulting. Okay. So I have to also think through, okay, within this group, I think they are the highest group of customers who will default. So what is the exposure for these customers, right? What do I mean by that? What is the amount of money these customers, actually need to pay me back? Just in case the first customer exposure is 1,000, the next customer exposure is 5,000. So obviously, I will try to reach out to the second customer, because if I lose 5,000, that's much more compared to the first customer. In this way, we build different strategies. Okay. So who are the customers who should be contacted? First step is this one. This is the first step, right? Who are the customers who will be contacted? This is the first step. Next step is, okay, I know that there are customers who will default, but now out of these customers, who are the more riskier customers? That comes from balance. Okay. Now I know that within these two customers, the probability is exactly same. Within these two customers, the probability is exactly same, right? Now, whom to prioritize? You prioritize the customers whose exposure to default or balance to default is more. In this case, the second customer. In this case, maybe it can be 10,000 and it can be maybe 80,000. I pick up the next customer, right? In this way, guys, you decide which customers to pick up. So at the end, you're consuming the output of a model. This is nothing but output from a model, right? Output from a model. You're trying to build different strategies across using the output from a model and other intrinsic parameters to build a strategy, okay, whom to contact. Okay. So that's the way, guys, you actually create strategies from the output of a model. Right? And I think how to create a model, you can look at proc logistic in SAS. That's a very easy way to how to create a logistic regression model. You get probabilities for each customers at a customer level, right? I'll share the data which we have used in a couple of classes previously. You can use that data itself, and you can build a very quick logistic regression model to come up with these numbers of these probabilities, right? So I'm not going to detail because it's just a 6 hours session, right? That's the reason the expectation is not that we will actually build a model in class, but I can talk about how do you consume output from model, right? Yeah, but since again in the essence it's a SAS workshop, it's imperative that you know how to build model in SAS. That's the reason I told you the basic syntax of proc logistic, that you use proc logistic to build a model. But yes, please go through the web. I can share a few good articles with you which clearly explains how to use proc logistic. It's very easy, right? Or if you have any questions, please type down the questions in the YouTube video. We'll be more than happy to answer those questions. So after you get output from a model, the next step is you profile the customers basis different other exposures, right? For example, in this case, depending on balance, I decide which customer to reach, which customer to not reach out. Now that process is not very easy, right? Now the next step is, okay, I know that I will reach out to customer 11 and I'll reach out to customer 17 in this case, right? But how to reach out to? How to reach out to is another question. So there are different channels which you use to reach out to a customer. You can either call the customer, you can drop a mail to the customer, you can SMS the customer. So which channel will you use to reach out to the customer, right? That's the next leg of the problem. So for that, you can also build very similar models which you saw, which I had built for finding probability of default. Now imagine that there are 4 channels, maybe SMS, DM, then mails, and maybe push, mail and push, email and push. So imagine that there are 4 channels you have. I would want to build again statistical models basis these channels. So for each customer, I want to find a probability that a customer responds to SMS, probability that a customer responds to DM. Similarly, probability of a customer responds to email and probability of a customer responds to push. And in this way, you will have probabilities at each channel level. What is the probability that you respond if you are contacted using these channels? So ideally, we can build even models at that level, right? So imagine that, okay, First level, I knew it was 11 and 17. So for 11, I have 4 options to reach out to the customers: SMS, DM, email, and push. For SMS, I know the probability that the customer will respond is 0.5. DM is 0.6. Email is 0.8. Push it's maybe 0.5. So ideally now what I should do for customer 11, I should reach out to the customer 11 by dropping in a mail. Because now this gives me another level of comfort that, okay, now my decision is actually driven by data, right? I reach out to the customer using email because my model says that the propensity or the probability of a customer responding to the email is much more compared to the other channels. That's the next leg. Okay. Now, next leg of the problem is, okay, now I reach out to the customer using email. Now is when. When do I reach out? So imagine that you have again a model which says that, okay, you've divided the day into maybe segments like, maybe 6 to 12 p.m., 12 p.m. to p.m., again maybe 6 to 12 a.m., 6 a.m. obviously, right? Divided the day into 3 windows. Okay. Now I want to find, okay, I know that I should reach out to the customer using email channel, but when? During which window? So imagine that you have probability also for these windows, 0.4 and 0.686. Okay, and this is 0.2. I can clearly see that within this window, the customer has maximum probability that the customer actually responds back. So essentially, going through the entire chain of sequence of events, firstly you decide which customer to reach out to, how to reach out to, and when to reach out to. In this way, you're optimizing the entire customer journey and you're hyper personalizing your way of communication to reap maximum benefits. Right? So these are the type of, I would say, strategies which you build, while having statistical models in place. Right? So now the main question is, okay, I reach out to the customer saying what? Okay, I email the customer saying what? So now you have to default. Now you have to decide, what do you say? Why are you reaching out to the customer? Right? Maybe now you reach out to the customer with a strategy that, okay, I know that you'll default using these channels at this time. I think you can convert your pending amount of money which you are to give this month. But I think, in case you don't want to pay, obviously it cannot be that blatant telling the customer that we have a model which tells me that you default, right? That's not the way it happens. But just you reach out to the customer, in goodwill and say that I think if you need any help in paying back the money for this month, you can maybe convert your, existing balance which you would need to pay the exposure amount to a further EMI, or maybe you can ask for a loan from me. I can give you another loan, right? So in this way, the final action happens. Converting the balance to another loan. So it's a very typical banking use case, guys, which I took today, because it was a continuation to what I did in the previous couple of sessions, just to show you how to use model outputs, how to use them, right, to drive strategies across the entire value chain, right. I think that's what I wanted to cover broadly today, right? How to use model outputs. And yes, if you want to go into much detailed technical, stuffs of how to build a model in SAS, we can, obviously take that up separately, right? But for now, this was there. This was till what I had planned for a workshop to cover basic ways how to play around with data, manipulate with data, right? Followed by a session where you actually have model outputs. Obviously dummy model outputs, and how can you use or leverage the model output in developing a strategy that actually goes to the end result, right? That actually sees the day of the, light of the day, right? So I think this is a very important, I would say, value chain which you should understand, and you should be aware that, okay, Developing a model is not the end of all of everything. Consuming the model output and building strategies on top of it, right, to make intelligent decisions, which actually drives business impact, is the main essence of the entire analytics value spectrum. So I think with that, I would like to, leave you with some thought that, okay, it's not about just being geeky, but it's also about, solving real-time business problem. And that's a way how analytics has evolved. And that's the way actual value addition happens in the industry, right? Be it across any vertical, be it a bank, be it telecom, be it a retail, a technology, oil and gas, anywhere, wherever you develop a model, the end result is consumed while for building a strategy, right? That's the most important thing of the entire spectrum once again, right? So if you have any questions, please feel free to write your questions in the YouTube video itself. We'll be more than happy to answer. For with that, I close the session, today's session, and also I'll also share the codes which we have used in the couple of sessions earlier, along with the data which we had used earlier. It was from Kaggle. So you can look up the data from Kaggle, download it, and try to play around with data using SAS. Also, you can think through a bit how to develop models, which we haven't covered, I know, in details. But I would request that you go through proc logistic. That really helps how to build logistic regression models in SAS. So with that note, let's end the class. And yes, I think all of us, had a good time in these 3 sessions. Have any questions? Please feel free to reach out to me directly over LinkedIn or reach out to Board Infinity, and we'll be more than happy to answer all your questions. So have a nice day ahead, and please, be safe and wear mask. Obviously, that's the most important thing I can tell you. And try not to be outdoors during this, pandemic time. Let's so that all of us are safe, and you also take some moral responsibility, social responsibility to curb this vaccine down. Okay, everyone. So let's end this session with that note of be safe, be positive, and all of us will come out of this really strong. And in the meantime, spend some time learning analytics, learning nuances of analytics, and I think you'll be better positioned for tomorrow if you want to move into a quant role or a strategy role, because those are really interesting, and I would say the has gained a lot of traction, I would say, right, during this lockdown and pandemic, because all of us are looking for digital transformation, and that's the point where these roles come in very handy. And yes, everything is moving to database-based decisions, and we are no longer relying on gut feeling anymore. Okay, so with all of that, let's end the session. And it's been a pleasure, right, hosting this seminar for all of you. And I hope that this was fruitful. I have any questions, please again, once again repeating, please feel free to reach out to me directly over LinkedIn or directly post your questions over the YouTube channel or the YouTube videos. We'll be more than happy to answer those questions for you. Is proc logistic same as logistic regression implementation? A question. Yes, exactly. Proc logistic is logistic regression implementation. Exactly. Yeah, Simran, exactly. I mean, I've been promising you since a couple of days. I haven't sent a link for this data set, so I'll share the Kaggle link for this data set where it is there, right, along with the codes with you, so that all of us are aligned and the same page. Have any questions? If you do not have any questions, then let's end the session. I may wait 30 seconds, 30 more seconds. Simran, I'm not very sure what's the error. Graphic control, VM box is showing graphic control error. The URL that's given is not working. I think your virtualization is not enabled. You should go to the BIOS, BIOS, go to the BIOS and enable the virtualization, and then retry this once again. See if this works. 32-bit, 32-bit. Akhilesh, ideally you are using a VM, right? So 32-bit should work. I'm not very sure, but I can check and get back to you. 32-bit, if an use SAS University edition 32-bit, I'm not very sure. I'll check and get back. Any more questions? Okay, then let's wrap up the session. If you don't have any questions, please feel free to post your questions in the YouTube video itself. We'll be taking your questions from there. I will answer them, and I'll also share the link to the data as well as data with you guys, as well as the codes with you. Okay. Okay, then stay safe. Have a nice day ahead. Good day ahead, and wear mask. Bye bye. Stay safe.
Thank you so much, sir, for completing the entire SAS workshop for the back-to-back Sundays. And it was really an informative workshop. We have got pretty good feedbacks from the students as well. And that's really the things we are delivering to the students. Apart from that, dear students, if you think that this kind of workshop is actually helping you learn something productive, do share with your friends, peers, connections, and all. And don't forget to hit the like button and subscribe to Boring Free channels. Once again, thank you so much for being a lovely audience.
Thank you, everyone.